All right, so plan for today. Here's where we're headed. We've got kind of things reworked. Number one, I want to go over question 75 because as people were turning in the assignments, some people left it blank. Some people said they had questions. Some people, you could just tell, needed help on this one. It's not that bad. It's just whether you remember it or not. Then put the phone away. So if we take a look, if we are finding in this section, they're asking you to basically find the zeros and then sketch the graph is the idea. Okay. We know since this is a positive x cubed, we know in general that the graph is going to look, let me switch this, something like, something along, oops, hang on, forgot, froze that. There we go. Something along those lines. That's kind of the general idea of the graph, okay? And we're going to find the zeros so we can add a few specific points to that graph. So, if we set this equal to 0, first thing you should always look for when you're finding zeros, regardless of the equation, first thing, can I factor this? Okay, because that's the number one thing you're looking for. And we'll see if you remember back, we talked about this in chapter P. Okay, we haven't talked about it since. We didn't do a ton of it. You talked about it last year. Anytime you have 4 terms, what should you be thinking of, hopefully? Some people remembered, some people did not. Factor by grouping. Factor by grouping is the idea on this one, okay? And so if we take a look, here's the concept that we can do. And sometimes you can do it, sometimes you can't. We'll talk about that as well. That'll lead into today as well. So if we go through, I'm going to group the first 2 terms together, and I'm going to group the last 2 terms together. Okay. And now we take a look, what can I factor out is the idea. So if I take the x squared out of the first one, that leaves me with x plus 3. In the second one, I can take out a negative 9. We can factor that out. And that leaves me with a positive x and a plus 3. Here's how you know if you can do factor by grouping. If I don't get the same thing or I can't get the same thing in parentheses, factoring by grouping doesn't work. You have to get the same thing inside the parentheses. Okay? And you'll see that, like I said, today as we move forward. Problems like that where it doesn't work. And then we go to the next option, which is what we're going to do today. So when we factor by grouping, now we have 2 factors that we can write down. Factor number 1 is the stuff we took out. X squared minus 9. Okay? X squared minus 9. We can put that together. That's one of your factors. The other factor is the stuff that was in parentheses, the x plus 3. And now you took your cubic function and it's factored by grouping. Okay? And now we can finish this off and we can solve from here. We can factor x squared minus 9. It's a difference of squares. So we have x minus 3 and x plus 3. And then we still have this x plus 3 as well, equal to 0. And now from here, 0 product property. So first 0 that we have is 3. And if you notice, we've got 2 of these x plus 3's, which means we really have negative 3 is 1, 0. But what's happening at negative 3 on the graph? Yeah, that's a double root, so it bounces off of the x-axis and goes back the other direction. Goes single root means it goes through the x-axis. Double root means it bounces off of the x-axis. So if we put that together, let's just kind of sketch this real quick. There's your zeros, 3 and negative 3, but negative 3 is a double root. So if we put, let's say we put negative 3 on here, and let's say we put positive 3 on there. We know it's got that general shape. At negative 3, it's going to bounce off of the x-axis. So it's going to look something along these lines. It's going to bounce off of that, come back down, and then at some point change direction and go back through positive 3. There's your sketch. Okay. It's got the general shape based on the fact that we started with a positive x cubed. And then we've got the zeros. Double root bounces off, single root goes through. Okay? Like I said, main reason I wanted to go over this was the number 1 problem that people were, you could just tell as they were turning in assignments, were struggling with. And I just wanted to refresh your memory on the factor by grouping. Okay? Any other questions we have? Yeah, Carter?
77.
77. Let's take a look at that one. So here is problem 77. Same idea, okay? Same concept in general to start off with. We're trying to find the zeros. We're trying to generally sketch the graph. So again, I'm going to set it equal to 0 so I can find the x-intercepts, the zeros. In this one, we talked a little bit about this yesterday in a different problem. Let's clean this up a little bit. Let's make it a little bit easier. What should we do? Multiply everything by 4, and I'm actually going to go -4 so that the first term's not negative either. Okay? So if we multiply everything by a -4, we get t to the 4th minus 8t squared plus 16 equal to 0. Okay. Quick question, by the way. General sketch of this graph is going to look like what? W or M? Original problem means it's going to open down. Okay, it's going to be that M shape. Okay, because you've got a -1/4 t to the 4th. Now, when we solve this, this is just a factoring problem. Okay, we can factor that. This is a quadratic. We have, if we put our factors down, at least I think we can factor this. Yeah, we can. Instead of t and t, what's going to go in the first spot? T squared. Yep. T squared and t squared. What do the numbers have to be so that I get a -8? -4 and -4. Which means you'll end up with a positive 16. You put those together, you do get a -8t squared. And now, once again, you go through it. You've got two sets of difference of squares here. This is t plus 2 and t minus 2. And then you have another t plus 2 and t minus 2. Which means we've got two double roots. Okay? At the t plus 2, those two kind of go together. You got -2 as one of your roots, but it's a double root, so it's going to bounce off the x-axis. And same thing here. You've got two of those factors, so +2 is also a double root. Going to bounce off of that as well. So again, if we put that together and we sketch it, here's -2, here's +2, and we know it looks like this. Going to come up, bounce off, come back around, bounce off again, and there's at least a general sketch of your graph right there. Okay? General shape plus the fact that we know the zeros are double roots. Making some sense, hopefully? Getting the idea? Okay. Any other questions, or are we okay? 57. Yeah, 57. Ooh, let me do that one individually, only because that one's long. Let me come individually. So what I would refer you back to on that one is the last example we did yesterday, the 2 plus square root of 7, 2 minus square root of 7. It's the same idea, just different numbers. Refer back to that one, and if there's some time to work, I'll come and help you, okay? Just because I want to make sure we can get through the stuff we need to today. Okay, so let me show you where we're headed today. I have this sheet, so I'll give you this. You don't have to. I've got 4 examples we're going to go through. Okay, take a look. So here is where we are headed. Everything we've done so far, you've been able to either factor or quadratic formula. You've been able to find the zeros. Okay? Where we are headed is, what if I can't factor? What if I can't do the quadratic formula? What are my options? And we're going to split it into 2 days. Day number 1, today, synthetic division. We go back to synthetic division and work our way through that. Option number 2, last resort. Cry. Not cry. Hey, that's what Connor said yesterday. Cernutsky was going for crying too. No crying. Yeah, exactly. Option number 2, which is usually your last resort if you have to, long division. But there are times where that's the only option. So that's why we'll look at that tomorrow, and then we'll go from there. Okay? So let's take a look. Notice what we are doing on this. Find all real and complex zeros. The reason why it's not just real zeros now, complex meaning we're adding back in the idea of you might have imaginary zeros. Okay? We'll talk about that today. We'll get into that. It says use the graph and the remainder theorem to start. Give exact answers, meaning don't take the square root of something and put it down as a decimal. Leave it as a square root. Reduce it if you can. Leave it that way. Okay? First question. Let's go. Let's start with problem number 1. We're looking for the zeros. If I set this equal to 0, first question you should have on this one, if you've got 4 terms, can I do factor by grouping like we did on number 75? And what's the answer on this one? Can I factor this by grouping? Yeah, you can. Okay, here's why. Here's how you can tell. When you go through, you group the first 2, you group the last 2. What you are looking for is when you take out a greatest common factor, do you get the same thing in parentheses? If the answer is yes, you do factor by grouping. If the answer is no, then you got to do synthetic division, which we'll talk about on problem number 2 in a second. So let's do this one again real quickly here. First part, we take an x squared out. You're left with x plus 3. Second factor, you take a minus 2 out. You're left with x plus 3. That is why factor by grouping works. I got the same thing in parentheses. If that doesn't happen, then you can't do it. Okay? So now we split this into factors, just like we did on 75. The stuff you factored out is your first factor. And the stuff in the parentheses is your second factor. And now we go to zero product property to finish this off. Answer number 1, we get x equals negative 3. Answer number 2, if I set this equal to 0, add the 2 over, take the square root, we end up with plus or minus the square root of 2. And that's what they mean when they say leave them in exact answers or give exact answers. Don't type in the square root of 2 and get 1.41, whatever. Just leave it as the square root of 2. Okay? If I was asking you to graph this, then I would type that in and actually use the decimals to kind of approximate where the x-axis, where the x-intercepts are. But that's not what's being asked here. It's just find the zeros. There they are. We got 2 not so nice ones and 1 that's a little bit nicer. All of them in this case being real zeros, 3 real zeros. Okay? So this is a quicker method if you can factor by grouping. So that's the first thing you should always look at. Take a look at problem number 2. Can I do that one by factoring by grouping? No. If you combine the first 2, you can take an x squared out. You're going to get 2x minus 1. There's no way I can get 2x minus 1 over here. Okay, matter of fact, there's not really anything you can even take out over there. So we can't factor. Here's the situation where synthetic division comes into play. Okay? Next thing I need you to do, in order to get started, take out your graphing calculator. Okay? We're going to use the graphing calculator to get us started on this one. And what I want you to do is in your y equals, type in that equation. Type in the equation into your y equals on your calculator. Type the equation in. Number 2. It is on the sheet of paper right in front of you. Just a heads up. Oops, not what I wanted. Different button. So here's the idea. Here's why we're starting with the graphing calculator. In order to do synthetic division, you need a real zero to start with. Okay? You got to have something to start synthetic division. So we're going to use the graphing calculator to find it. Just to quickly answer a question. Remember I told you you're not going to have a graphing calculator on the test? To answer that question, well then how do we do synthetic division on the test? We'll give you the graph or we'll give you the first zero. Okay? So we might just tell you, find the zeros if you know the first one is 5. and then you go from there and do the synthetic division, okay? But we're going to use, for now, we're going to use the graphing calculator to find the first one here. So when you type this in, I'm going to go, let's go to Zoom 6, okay? Hit the Zoom button. Number 6 will take you to the standard window again. That way we reset everything if it got reset. And you may or may not be able to take this directly off the graph. It might be nice. We can see here's a 0 that's not very nice. Looks like it's between -3 and -4. Looks like it's crossing at +1. Looks like there's another 0 at 3. To confirm that that's what's actually happening, we're going to use the table. Okay? So a new feature we haven't talked about yet. First one, we're going to go into the table setup first. So you need to hit the second button and the window. Okay? Right next to the y equals button. If you notice in blue, it says table set. That stands for table setup. You see this screen right here. Couple things we need to do to get this set up to begin with. Doesn't really matter where it starts. I'm going to start it at 0. Okay, so I'm going to change that to 0. The next line is asking you, delta table means what do you want it to go by? 1s, 2s, 5s, halves. What do you want to go by on your table? Well, it looked like we had whole numbers, so let's just go by 1s. And then you want auto for the other two. Okay, make sure you have auto for the independent and the dependent variable, so it will automatically calculate the x's and the y's for you. Okay, and now we're going to go to the actual table. So you hit second and the graph button. Again, if you notice right above, there's your table of values that go with what you typed into your y1, your equation. So here's all the different x values. If I were to plug in 0 to that equation, I get 21 out. If I plug in 1, I get 0. If I plug in 2, I get -11. It's a table of values for the equation. Okay? Notice, we said it looked like at 1 and 3 we had a 0. Sure enough, we do. There it is. Okay? Now, in this case, and we'll talk about when you would need more than that, but right now I only need one of those zeros. Okay? I only need to use one of them. And we'll talk about why in a second. So now let's go back to the problem. That's the only thing you need the calculator for, is to get started. Okay, to get started on that. So let's go back to the actual problem. It does not matter. We just said we had zeros I'm just going to put it off to the side. We had 1 and 3 are zeros. Pick one of them. Doesn't matter whether you pick the 1 or the 3. In the end, you'll get the same answer. And now, here's your review on how you do synthetic division. Okay? I'm going to choose the 1. For no good reason whatsoever, I'm just picking one. So if I take 1, I'm going to put it in a little box here in the corner. And the nice part about synthetic division is you take out all the variables and you just use the coefficients. So instead of 2x cubed, I'm just going to put down a 2. Instead of -x squared, I'm just going to put a -1. And then the -22 and the +21. Quick reminder, if you were missing a term, like let's say that -x squared wasn't even there, what would I have to put in that spot then? Don't forget, you got to put a 0. It has to go, you got to have placeholders. So it has to go down in order. Right? X cubed to x squared to x. If something's missing, you got to fill it in with a 0. Okay, you got to have a placeholder of a 0. And now here's the process. Okay? Whatever that first term is, you bring it down. Doesn't matter, you just always bring it down. And then we multiply by the 0. 2 times 1 gives me 2. And we add. -1 plus 2, 1. And then we go again. Take that, multiply by the 0. We get 1. And add. You get -21. Multiply by the 0. You get -21. Add. We get 0. I'm going to put a little box there. Does anybody remember what that 0 represents? That's your remainder. That's saying it went in evenly. Okay, you know that this is already a 0, so you should get a 0 as a remainder. Otherwise, you did something wrong. Okay? You already knew from the calculator that this is one of the zeros. So you should automatically get a 0 there. That's your signal if you're doing synthetic division and you don't get a 0, you did something wrong right here. Okay? if you know that it's already a 0 based off of the calculator. Now, here's the next part. We got a lot of numbers up here. We got to make sure you understand what they mean. So here's our first 0. If 1 is a 0, what's a factor? X minus 1. Going back to like we were talking about yesterday. X minus 1 is a factor. And here's the other nice part about synthetic division. Whatever degree you start with, every time you do synthetic division, it drops a degree. So these numbers right here are your coefficients of a quadratic. So you have 2x squared then, since we started with an x cubed, plus 1x minus 21. What you need to recognize synthetic division as, it's a method, it's another method of factoring. You just need a 0 to start. You just factored this to this. Okay? Again, these numbers are, it's always 1 degree less than what you started with. If I did synthetic division again, we'd drop it by another degree. This is why, and the goal always, by the way, is always to get to a quadratic factor, because now, how can I solve this quadratic factor? What do you always do with quadratics? One of two things. Factor it or quadratic formula. That's why we want to get down to a quadratic, because we have methods to solve already. We don't always have methods with cubics or quartics or things like that. You want to get it to a quadratic. So if we were going to finish this off, and I'm not going to do all the math on this one, but this would give me x equals 1 as a 0, which we already knew. And to find the other two zeros, I believe, pretty sure on this one, you have to do the quadratic formula. I'm not going to go ahead and do this one because I think you can handle it, but you would need to do the quadratic formula on that one to get the last two zeros. Okay? What is it? Oh, so it actually is factorable. You could factor it if it's negative 3.5. So that is factorable. You could do it that way. Okay? Or if you'd rather do a quadratic formula, that's fine too. You get those answers. Okay? Well, that's you're not going to have on the test, so just so you know. So good luck when you get to the test and you don't have polysymbol. Okay? Yeah?
Why did we get rid of the 22x instead of like 21?
So remember what you're doing is when you're working through, you multiply to get the number and then you always add.
Yeah.
Okay? So that's where this negative 21 is coming from. And so ultimately, does that make sense?
Yeah.
You're multiply, add those to get that.
Yeah.
Multiply, add those to get the next one. Okay? Any other, before we go on, this was kind of your first refresher. Any questions on this problem before we move on to anything else? Okay. So there's your refresher and the idea. Two main things I want you to understand. The process, obviously, you need to know. But I want you to understand that synthetic division is really just a method of factoring. And two, you have to go through and we have to get down to a quadratic. That's what we're trying to do. So I only needed to do synthetic division once to get there. Okay? All right, let's go to the next one. Take a look at number 3. Now, quick question. How many times am I going to need to do synthetic division on this one? Twice, because we're starting at an x to the 4th. Which means, when you type this into the calculator, how many zeros do you need to find? Total, we're going to have 4, but how many do you need to do the synthetic division? 2. You got to find 2 real zeros to do the synthetic division to begin. So type that into your y equals. Type that into your y equals, and then again, we could go straight to the graph. We're going to want to have to confirm with the table regardless, so you could just go straight to the table as well. Okay? I'm going to go straight to the table. And oops, see if we can find, something's not right. What did I do? Oh, I put minus something. Oops, let's get rid of that. There we go. And so there's your table. is your standard window. Zoom 6. It'll reset it. If you wanted to take a look at the graph, here's what the graph looks like. Okay. Looks like it's going through at -5. Looks like we have another 0 at +1. Obviously, we can't see the whole thing, but it looks like we're at -5 and +1. Double check on the table just to make sure, okay? Because it might not be. Well, if you take a look on the table, yep, +1 is a 0, and if I go negative, sure enough, -5 is also a 0. There's the 2 zeros I needed, -5 and +1. That's all you need the graphing calculator for. Now we go back to actually do the problem. And like I said, when you get to the test, we will either give you the graph or we'll just give you the zeros. You will have that information so you just can start. Okay? You're not going to have to do the graphing calculator part. We just said -5 and +1 are 2 zeros. Again, does not matter which one you start with. Just pick one and go. Okay? Quick question when I'm going to go -5 to start. When I go through and put the numbers down, do I need any zeros? Are there any missing terms? No. We've got an x to the 4th, an x cubed, an x squared, an x, and a constant. So we don't need any zero kind of placeholders. So let's put the coefficients down. 1, 4, -1, 16, -20. And now we're ready to do the synthetic division. Okay. Bring the 1 down. Whatever's in the first spot, you always bring down. And then it's just a bunch of multiplying and adding. Multiply by the 0, and then add. You get -1. Multiply that by the 0. You get a +5. Add. You get 4. Multiply that by the 0. You get -20. Add. You get -4. Multiply that by the 0. We get +20. Add. You get 0. Why should that make sense that I get 0? Because it's a 0. You know it's a 0. We took it off the graph. Okay? Let me stop for a second because I see some faces of trying to catch up, making sure we're understanding. Questions on anything? Anything you need me to explain again, or where the numbers are coming from?
How are we going to find 0?
I'm going to give it to you. You'll either have the graph or I'll just give you the 0. I'll give you something to start with. I just mentioned that, by the way. All right. So now, if we notice, quick question, by the way. These numbers right here are the coefficients of what degree polynomial? X cubed. We started with an x to the 4th. These would be coefficients of an x cubed. We could go and try to do factor by grouping at this point if we wanted to. I'm just going to keep going with synthetic division. I'm going to grab you don't want to use a 0 twice. Okay? So I'm not going to use -5 again. I'm going to use the other one. Let's take the 1 and let's go again. Okay? So, if we go again, bring the first term down, multiply by the 0, we get 1, +1. Add, we get 0. Multiply, we get 0. Add, we get 4. Multiply, we get 4. Add, sure enough, there's our next 0. Works out again. So now, if I were to write this just in factored form, -5 means my first factor is x plus 5. +1 means my second factor is x minus 1. And my third factor is coming from these coefficients at the end, which, what degree is this? Squared, because we've done synthetic division twice, so now we're down to an x squared. This is 1x squared, 0x, so I'm going to leave that out, plus 4, equal to 0. You've taken your 4th degree, and now you've factored it into this. And now we finish it off to find all the zeros. Okay? So, 0 number 1, x equals -5. We knew that already. 0 number 2, x equals 1. We knew that already. last 0, if I take the x squared plus 4, and I set it equal to 0 and we solve, subtract the 4 over, take the square root of both sides, meaning you have a plus or a minus. So x equals plus or minus, what's the square root of negative 4? It is imaginary. Specifically, what imaginary answer?
I squared 4, 2i.
2i. Okay? If you take the square root of both sides, the negative just comes out front, or comes out of the square root as an I, and you just take the square root. Okay? You just use the square root like you normally would. So in this case, we are going to get 2i. So we have 2 real zeros and 2 imaginary zeros. Okay? Meaning, by the way, let's make one more connection. How many zeros would I actually see on the graph? You're only going to see the real ones. Okay? So it's not going to cross the graph 4 times. It's only going to cross twice because you have 2 imaginary zeros. Okay? One thing I want you, this is something else we're adding in today besides synthetic division. If you have imaginary zeros, I don't want you to just say not real or imaginary. I want you to find them. I want to know what are the actual imaginary answers. We can't really use them on the graph or anything because they're not there. But I want to know what those final answers are. Okay? And tomorrow we'll use them even more. Let me stop again. Question at all? Anything here that did not make sense? Yeah, Carter?
So basically what you're saying is if you can square root something and it's imaginary, you can square root to become imaginary, but if you can't square root it, it's just square root like 5.
Yeah, correct. Yep. Yeah. Yep. If it was not the square root of a negative, then just leave it as your square root, like that square root of 2 one that we did. Leave it like that. If it does have a negative, it should have an I in the answer. Find the I. Okay? Last one. Here's what I want you to do. Try this one on your own. Number 4. See what you can do. Take that equation, plug it into your calculator, find a 0. How many zeros do you need to find to get started? 1 to get started because you're at a cubic. You're only going to have to do synthetic division 1 time here.
All right, team, let's go.
Go ahead and find it. I'll give you about 5 minutes here. We'll see if it takes that long. So it'll get fixed either way.
Yeah.
Hopefully you found -1 was just 0. That's what you should have found. -1 is the 0 that you're using for synthetic division.
Yeah, but the issue is actually so now
there's what your graph should look like. That's what, when you graphed it. There's your -1 as your 0. Quick question, by the way. Let's make another connection. Are the other two answers going to be real or imaginary? How can you tell just by looking at the graph? There's only one time it crosses the x-axis, so the other two answers are going to have to be imaginary. Okay? So you're going to have to do quadratic formula to find those imaginary answers. I think. Yeah, off the top of my head, I think you do.
No, I put plus or minus 2 plus 2i. Which I mean,
All right, take a look up here. So here's your synthetic division. Like I said, you should have found -1 from the graph. Do the synthetic division. Again, we didn't have any missing terms, so I didn't have to put any zeros in. You do get 1, -4, and 5, therefore x squared minus 4x plus 5. Now that does look like it's factorable, but it's not. Anybody tell me why? Why is that not factor even though it looks like it should? What's the problem? Yeah. If I tried to factor this, we'd factor this into x and x. We'd factor this into 5 and 1, and you'd say -5 and plus 1, and everything works except -5 times 1 is not positive 5. So it doesn't work. There's one sign that doesn't quite work out. So that is not factorable. You have to do the quadratic formula, okay? And if you do the quadratic formula, let's do it real quickly together. I want to show you what you get as you work your way through this. So opposite of b is 4 plus or minus square root of b squared is 16 minus 4 times a times c all over 2a, which in this case is 2. Okay. Now we focus on the square root. Remember, I've told you this before, the biggest part to be careful of. Look at these three numbers. And make sure you then determine, are you going to keep it as are you going to have a subtraction sign, or are you going to end up changing it to an addition sign? Okay? Addition, if you have two negatives, then you're going to be adding. If you don't have two negatives, then it stays subtraction. So we are going to subtract. In this case, we get 4 plus or minus the square root of, we get 16 minus 20, so -4, all over 2. And now if you go through again, square root of -4 is 2i. And last part, simplify if you can. In this case, we can. Everything is divisible by 2. So we can basically break this into two parts. 4 divided by 2 is 2. And then 2i divided by 2 is i. There's your last two imaginary answers. 2 plus i and 2 minus i. Okay? Okay. 2 plus i, 2 minus i. Okay? All right. So like I said, there are times where you have to do synthetic division where you can't factor. Okay? And where we're headed tomorrow is there are times where synthetic division doesn't work either, and you have to go through and do long division. We'll talk about that tomorrow. I'm going to give you the assignment. It's going to be the same worksheet between today and tomorrow. I'm just going to have you do some problems today and some problems tomorrow. So make sure you hang on to this. Here is the actual assignment. And once you have this, I'll mention something else too. Easier way for you to do this. Make sure you circle the problems that you have to do today, or star them, or whatever. Just make sure you have those ones taken care of. All right, like I said, two things about this worksheet. Number one, make sure those 5 questions are all you have to do. 23, 25, 27. Skip 29 and then do 31 and 33. Second thing, I'll help you speed up the process on this one as well. Okay, I did. I did give you the answer, which actually is where I'm going. So I told you when you get to the test, you're not going to have to use the graphing calculator. Well, if you notice, like on number 23, I gave you that the first 0 is -5. Just use it. You don't have to go through and type this in and figure out that it's -5. It's literally sitting right there. Just use the -5, do the synthetic division, and find the other answers. Okay, that's how it will be on the test. Okay, it'll be, here you go, here's something to start with. So that way you don't have to do the whole graphing calculator part either. Okay, there you go. Tomorrow we'll go over any questions if you have it, and then we'll get into the last part that we're going to talk about.